All right, so this is a picture, and now let us prove that this is actually an equivalence relationship. So an equivalence relationship will satisfy three axioms or three properties. The first one is called reflexivity. Which says that if A is equivalent to itself. Okay. So how do we prove this? Now, since H is a subgroup, that means that E is always an element of H, right? So that means that if so that means we can write A is equal to A times E, which has the form of A equal to AH, right? Right, this is what we were looking for. Here A and B are the same, but H is the special element E. Okay? Maybe I should have written B here, but so it's almost trivial, but actually it's not. Okay? So that means that we have proved that A is equivalent to itself. It's sorry, the reflexivity property is satisfied. Number two is symmetry. So if two elements, if A is equivalent to B, then that implies that B is equivalent to A. So since A is equivalent to B, we can write A equals to B of H. But then what we can see is that we can write B H inverse equal to B. Or B is equals to AH inverse. But H inverse is an element of H. So this thing has the same format, same structure as this equation, right? So that means that B is equivalent to A. Okay, so symmetry is proved. Number three is transitivity. A friend of mine told me that friendship is not an equivalence relationship because while it satisfies, this one and this one, it doesn't satisfy the transitivity property. Okay, what is the transitivity property? If A is equivalent to B and B is equivalent to C, then that implies that A is equivalent to C. Okay? And this also is very easy to show. Suppose that since A is equivalent to B, we can write A equals to BH1, and B is equal to, say, CH2. And now all we have to do is that replace the expression for B into this equation. Then we get A is equal to CH2H1. But this is a group. H is a group, so H1, H2 will give you some other element, say H3. So A is equal to CH3, and therefore A is equivalent to C. Okay, so we have shown that the coset equivalence, the coset construction is an equivalence relationship, okay? So as an exercise, and you don't have to submit it because it won't be in the red box. You can show that if you have an equivalence relationship on a set, it divides the set into disjoint subsets, okay? Okay, any questions? I can always go over this more slowly or.
So can you reiterate the question? I missed it a little bit.
Sorry, can you repeat the question again?
Yes, sir. Can you repeat the question? You repeat the exercise.
Oh, I was just asking, should I go over the whole thing again?
Oh, no, the question you mentioned before.
Oh, the question, the exercise.
Right.
So, I want you to try this, try this at home. Any equivalence relationship, divides a set into disjoint subsets. Okay. So this is a very common notation for equivalence relationship. However, the next one is an exercise I would like you to do. Sorry. I don't know what happened to my, there you are. So this is an exercise I would like you to do. And this is, oh, sorry. Show that fractions A over B, where A and B are integers with B being non-zero, form equivalence classes. Okay, so what do you have to do? You have to show that the definition of fraction satisfy the three properties, okay?
স্যার এখানে ইকুইভ্যালেন্স রিলেশনটা কি?
Being a fraction, right?
So is this the mathematical fraction like 1 divided by 2?
Yeah, so for example, I don't know, 1 by 5 is equivalent to, say, 5 by 25, right? So it's basically this thing under division, the usual division and stuff, simplification, right? So show that this is an equivalence relationship, okay?
Well, isn't there an equality?
It is, isn't that equality?
Equality is trivially an equivalence relation.
Yeah, or you could say that this is how we form division for whole numbers, right? Yeah, it's very trivial. You're right. It's just that I want you to think about equivalence classes. Like when it's just I wanted to show that you're right. It is an equality. And it's from that point of view, it's a triviality. But I want you to think about the fraction as having this structure that we usually never thought about. So here I am kind of introducing this notion, where it's a new notion, right? For some people. But the reason why I want you to think about fraction as an equivalence relationship is so that you can realize that it's actually something you've encountered elsewhere, but you haven't thought about it in that way. Okay. I think Otun is right, but it's kind of a triviality, but even then, just think about it, okay? Like, so for example, 5 by 25 and 1/5, why are they equivalent? They're equivalent under some rules, right? So if if you didn't know,
Sir,
yeah.
এখানে একটা question ছিল আমার যে A আর B equivalent যদি বলি, in that case, like how do we like construct the equivalence relation between them? Like what does A equivalent to B mean in this case? Like you said that being a fraction, but I got confused.
Yeah, I think the question is not very well formulated, so you have every right to be confused. So what I'm saying is that, suppose that you have two numbers of the form A and B, right? And they are, so this is this guy and this guy, right? And so, our usual rules of algebra is telling us that this is equal, right? And that's basically what I'm saying is to think of it as an equivalence relationship. And as Otunu pointed out, equality is an equivalence relationship trivially, right? Having said that, I think it's still very instructive to think because, if you think about, say, the number line, yeah, so Nahi, does that make, clear, answer your question, what I mean by A over B?
Kind of, sir.
Yeah, so yeah, it's trivial, but I want you to think about it anyway, because it's, just to kind of show you that, we have seen equivalence relationship elsewhere in life, okay? Yeah, so don't worry too much about it, but, I just want you to kind of think about it a little bit more.
Yeah, I just want to point out something that we learned in real analysis, that when constructing the rational numbers, we basically define the rational numbers as equivalence classes, and basically we define two fractions to be equivalent. Like we say A over B is equivalent to C over D if AD is the same as BC. So I think that might be a better way to reformulate this question.
Okay, so Otunu, why don't you do one thing? Why don't you reformulate the question and post it on Slack, okay?
Yeah, sure.
Yeah, because you have more of a mathematical background than I do, so that question might make better sense. So just reformulate it, maybe take it up in a couple of lines and submit it on post it on Slack, okay?